The region rho less than 5 meters has a uniform volume charge density of 2 coulombs per meter cubed. And we're going to use Gauss's law to determine the electric field everywhere. From the cylindrical symmetry, we know that the form of the electric flux density field will be only having a component in the rho direction and only depending on rho. The appropriate Gaussian surfaces will have a cylindrical shape, and we will need two of them. We will need to apply Gauss's law when the radius rho of the cylinder is less than 5 meters, and again when the radius is greater than 5 meters. And we'll call L1 the height of the inside cylinder and L sub 2 the height for the outside cylinder. So let's look at Gaussian surface 1 when rho is less than 5 meters. So the integral of d dot ds is going to equal our charge enclosed, which will be the integral of rho sub v dv. So since the electric flux density only has a component in the rho direction, this integral here is the integral over the top, the bottom, and the side of this cylinder. The only place flux goes through is the side. The integral of d dot ds over the top and the bottom is 0. So this reduces to the integral of d dot ds over the side. And the integral of rho sub v dv is just the charge inside this cylinder. And since the charge density we've chosen is uniform, the total charge inside that cylinder is rho sub v times the volume of that cylinder, which is pi rho squared L sub 1. Now, because of the form of D, on the side of the cylinder, D has the same value everywhere on the side, and everywhere it's in the same direction as the outward normal. So the integral of d dot ds over the sides will just be the value of D on the side times the area of the side. So that would be d sub rho times 2 pi rho times L sub 1. So 2 pi rho is the circumference of, say, the base of the cylinder, and L sub 1 is the height, so this is the area of the side. And rho sub v is 2 coulombs per meter cubed. Times pi rho squared L sub 1. So this r is really rho, the radius of our cylinder. So we can divide through by 2 pi L sub 1 and a rho. So we're left with d sub rho is equal to rho for rho less than 5 meters. Okay, so now we're going to go back and apply Gauss's law to the Gaussian surface when rho is greater than 5 meters. And the difference here is that the charge enclosed will not be a function of rho, because for rho being greater than 5 meters, the charge enclosed is always going to be constant. So again, we have Gauss's law. The integral of d dot ds is equal to the charge enclosed. And this integration will be exactly the same on the surface of the cylinder for our second cylinder as it was for our first cylinder. So we have d sub rho at rho times 2 pi rho L sub 2. So the only difference is we're using the height of our cylinder 2 here. And that is going to equal the charge enclosed by our cylinder of radius greater than 5 meters. So that will be the charge on the cylindrical region right here of height L sub 2 and of radius 5 meters. So that will equal rho sub v times the area of the base of that cylinder, which is pi rho squared, but rho is 5 meters, times the height of that cylinder, which is L sub 2. So rho sub v is 2 coulombs per meter cubed, and we have 25 meters squared L sub 2. So we can divide through by 2 pi and L sub 2, and we're left with d sub rho is equal to 25 over rho. So if we look at the units here, we have a coulomb per meter cubed times a meter squared, so that will leave us with a coulomb per meter. But then when we divide by rho in meters, the actual units we'll end up with are coulombs per meter squared. So we have d is equal to 25 over rho in the rho direction, coulombs per meter squared, when rho is greater than 5 meters. Okay, and let's look back to the result we had for when rho was less than 5 meters. Okay, so looking here, our units, we had coulombs per meter cubed, and then when we put in rho in meters, we'll be left with coulombs per meter squared. So back here, we see that the units are going to be coulombs per meter squared. So d is equal to rho in the a sub rho direction, coulombs per meter squared, when rho is less than 5 meters.